Good evening, everyone. Welcome to our inaugural AGC Glass lecture. I'm Scott Poole, Dean of the UT College of Architecture and Design, and I welcome you to our lecture tonight featuring James Carpenter. This lecture represents a key component in architectural and design education today, partnerships. At the University of Tennessee, our mission as a land-grant university is to create value for society. More specifically, our task is to contribute to the greater good in the communities we serve. Alone, we have a limited capacity to do that. Together with partners, we can achieve great things. The future of design education, especially in land-grant universities like ours, hinges on our ability to intertwine our internal creative culture with a durable portfolio of non-academic partners to evolve, grow, and choose to do what no one else can do. Will need substantial support from a broad spectrum of non-academic partners and a willingness to invent, adapt, and change at the pace of our innovative partners. Tonight's lecture demonstrates the power of partnerships and what can happen when academia, the professional world, and design-related industries come together. I want to thank John Murray, Vice President of Sales and Marketing at AGC Glass, who's with us this evening. John's an active member of our college's Dean's Advocacy Board, and he was instrumental in making the AGC Glass lecture possible. Thank you, John. I also recognize David Deal, Director of Marketing for AGC Glass, for your support of tonight's lecture. Thank you, David. We're thrilled to partner with AGC Glass, the world's largest glass manufacturer. For more than 50 years, AGC has brought economic prosperity to Hawkins County, Tennessee, just 90 miles northeast of Knoxville. In 2018, AGC invested more than $40 million in adding 100,000 square feet of manufacturing space to their existing facility in Church Hill, creating 85 new jobs and bringing economic prosperity to one of our East Tennessee communities. As architects and designers, we know the impact glass has made on the form of architecture, art, and design over the past century, and no glass manufacturer invests more in innovation or the innovation of glass than AGC. Let's watch a short video to experience AGC Glass's impact.
Smart cities of tomorrow will require a new, smarter generation of glass, and AGC is leading the way with BIPV glass, invisibly transforming a facade into a high-volume solar power generator with next-generation active tinting glass, maximizing efficiency, occupant comfort, and aesthetics. And with 5G antenna-integrated glass, keeping communities more beautifully connected. Smart cities are on the rise, and AGC is proud to help lead the way.
Thank you, AGC Glass, for funding tonight's lecture. The inaugural AGC Glass lecturer is James Carpenter. I've known James and followed his work for more than 20 years. What impressed me the most when I first visited his New York City office in the late 1990s was his intense curiosity, his absolute fascination for glass, and his interest in producing knowledge through research. Let's get started with tonight's lecture with Assistant Professor Miguel Guirgis, who'll introduce James Carpenter.
Good evening, everyone. Welcome to the University of Tennessee College of Architecture and Design AGC Glass Lecture. I am very excited to present tonight's guest speaker, James Carpenter. James Carpenter has worked at the intersection of art, engineering, and the built environment. For 50 years, he advanced distinctive vision based on the use of natural light and glass as the functional element of the built environment. Carpenter founded the cross-disciplinary design firm James Carpenter Design Associates in 1979 to support the application of these aesthetic principles to large-scale building projects. Carpenter has been recognized with numerous national and international awards, including the Academy Award in Architecture from the American Academy of Arts and Letters and the MacArthur Foundation Fellowship. He holds a degree from Rhode Island School of Design and was a Loeb Fellow of Harvard University Graduate School of Design, GSD. For the attendees, if you have any questions, please type them in the Q&A section and we'll address them later in our Q&A session after the lecture. Allow me to welcome James Carpenter. It's great to have you and thank you for joining us tonight.
Yes, hi, good evening, everyone. James Carpenter and AGC, thank you so much for the sponsorship of the lecture. And Scott, thank you so much for the invitation to come and speak to you in Tennessee. As Scott said, we've known each other for quite some time. We're just imagining talking about that when we were probably 20 years ago, actually, at least, and what's happened in those years since. What Scott was discussing in his introduction, I think, is this notion of collaboration and working together with partners on projects. And it's very much, I think, sort of an underlying structure of our studio here in New York, where we are a relatively small studio with people who studied fine arts, architecture, some in engineering. But we have very, very long-standing working relationships with several groups outside of our office, which we work with on almost every single project. One of them is Schleich Bergerman and Partners, structural engineer from Germany, who we work with for almost 40 years. Tri-Pyramid Structures up outside of Boston that do tensile structure fabrication, and Pfeiffer Structures in Germany. So this point of having partners who obviously can expand your capacity to produce work and who are experts within their own fields, and combining those levels of expertise allows you to do significantly more, obviously, than you can in a limited one studio sort of environment. But just to take you back a little bit in terms of my background and how it sort of came to be that this particular practice came into being, is that I studied originally at the Rhode Island School of Design. At the time, it was very much of a industrial design school as well as fine arts school. By that, I mean that it had full machine shops and foundry, huge textile department, and other facilities, ceramics departments, in addition to sculpture and painting. And I actually went to RISD in architecture to begin with, and stayed in the architecture program for about 2 years. But what happened when I was a student, and a little bit due to the organization of the school itself, is that when you're a student, you enter to do a program that's shared by all departments. You have sort of a foundations program that gives you an exposure to all the different departments, whether you're going into architecture or painting or sculpture. You know, you all share the first year with a few courses specific to each discipline. But that notion of exposing everyone to the broadest opportunities at the school was really quite an eye-opener for myself. And I found that my interests were really certainly within architecture, was certainly about light and sort of working with light as an opportunity, and then led me to want to work with glass as a material in particular. There was a very small glass program at RISD, just literally a few people in the program. It was a little bit of an offshoot of the ceramics program. And I just became very, very involved in the material of glass as a student, and then eventually began working with the material and with film. And I'm just going to take you into some of these first images. Sorry for that. Just starting on some of the earliest work as a student, I was working with film and working in glass simultaneously, and my interest in film had to do with sort of capturing particularly events or episodes in nature, sort of phenomena that occur in nature, and how one might document them in a certain way and then bring them into a gallery or museum environment so that people might experience that phenomenon in a little bit more of an active manner. And this is a a project done in Puget Sound, a series of scaffolding set up over a small river, series of cameras shooting down into the river, which basically allowed you to, in this instance, sort of capture a migration of salmon, sort of a salmon migratory movement up through this small river that was being managed by the University of Washington. And the interest in doing this is that you walk into the museum or you walk into the gallery, and this is probably about 70 feet long, this fragment of river. And you stand beside these images and you actually sort of see the movement of the fish going from one film frame to the next, as you can see here. But what you actually understand, the longer you look at this film, and one of the reasons this film looks a little staccato, is the timing is actually changed on the film in the sense that film frames are being held slightly longer than they would typically be held. And the longer you look at this image, you realize it's not just the fish you're looking at or the texture of the stones on the bottom of the stream, but it's actually the reflected image on the top of the water itself, which is of the sky. And this is fundamentally something that interests me in terms of our work here in the studio, is that the eye actually has a way of selectively pulling information out of what's in front of your view. And you pull out information that's you're very comfortable with. Sometimes you pull out information that you're a little less comfortable with, but nonetheless, there's a range of information and you're always in your field of view, and the eye tends to select that. And in this instance, what interests me is that you might imagine that stream essentially being sort of a plane of glass, let's say, and you have information that happens on the surface of the glass, you have information that happens within the glass or within the water, and then you have information beyond that surface or at the bottom of the stream. And how this field of information that surrounds us, how you identify it and pull it together. And this is a project done maybe 10 years later or 14 years later from that film. It's a bridge commissioned by a family in California, a glass bridge. It's about 100 feet long, and it's positioned off of opposite banks of the river. So the glass platform is essentially moving in the direction of the river. So your passage is walking out on this abutment onto the glass platform and then moving down this glass platform to the other side. So there's this idea that crossing the river is really more of a moment in time where you're actually allowed to understand the ecology that you're within, the environment you're within, and the qualities of light that make that particular environment so unique. So here you have the caustic reflections being broadcast up on the underneath surface of the glass platform, and then light transparent coatings on these pivot panels, which basically collapse and gather information of the surrounding landscape. So the idea here is passage becomes a deeper understanding of the environment where you are. So that idea basically, which was being done in the art world for many years in the 70s and the early part of the 80s, eventually led me to begin doing more collaborative work with architects to find ways of introducing some of these ideas into projects, into built projects, creating sort of new types of public experiences within these buildings. This is a tower here in New York. Just as an example, it's done with Foster. I sort of skipped a chunk of time in my background that I actually worked as a consultant for Corning Glass from about 1972 up until the late 80s. And one of the materials I worked on when I was there are photosensitive glasses, in particular one that's called photoform, a material that was used originally for sort of early integrated circuitry design, but in this case was adapted to producing cladding materials for a building. The building was the Hong Kong Shanghai Bank that I worked on with Foster, who's the architect of this building. And we've worked together with their office on many projects since then. But this is the Hearst Tower here in New York. And we worked with them on the lobby of this space. In particular, if you go into this early 1928 base of the building, which is the original podium of the building that was intended to have a tower put on it. Foster was hired, they sort of gutted out this podium, but it left you with this original entry, which is a relatively small scale entry into a large tower. So sectionally, looking at this section through the building, partial section. This is basically 8th Avenue outside the building. This is that entry we just looked at, a fairly small entry, the original podium of the building, and then clerestories and sort of skylights that create a large entry pavilion with enormous amount of daylight as you enter into the building. And what we did here is working on those areas was this inclined surface is in fact sort of a large scale periscope. And that I mean that if you're looking into the building from the street, this surface, which is made up of prisms, you're actually looking back out of the building to the sky beyond. So you're taking all of this daylight coming into the building and bouncing it out to the eye of the person on the street, meaning that when you look into the building, typically a dark environment in a building in New York City, because you can never overcome the amount of light on the street, all of a sudden this interior space has a similar light levels as the exterior. So you have this welcoming environment inside. And then this particular project, because of New York City, we're required to collect water within the footprint of each building. The water's collected on the roof, it's brought down, it's filtered and chilled, it's sort of stored underneath here. This area, there's like a mechanical room below here. And that chilled water is basically running down this glass prismatic surface, and it acts as sort of the cooling system for the main part of the public environment of the building. This idea of working with glass at this scale, this is just an image of one of our molds. They're milled out of graphite, a fairly dense graphite material. And what you're looking at is actually the texture of what will be the glass tile or prism that's poured into this mold. So this texture actually becomes the surface of the glass, and then all the glazing details are actually also in the mold simultaneously. So when these molds are filled, it's actually a furnace that's built on the second floor of a building factory. And the flow of glass is through a stream, a constant stream from above, filling up each of these molds, which weigh about 170, 180 pounds of glass per prism. Here you can see all the details for mounting the glass. This little piece here is actually where the glass, when it's installed, is flipped over, and that notch that you see rests on these brackets. So each of these blocks is spanning that dimension. So it's spanning from side to side. There's no support. And testing these blocks, they can hold about 4 tons of load at the center of each one. But the whole idea here is that they're designed in such a way that the light from overhead, coming down from overhead, you can see it. This is the light from the skylight overhead, and it's bouncing directly to your eye. So it's just using a clear glass. It's totally transparent, but the configuration of it is behaving as a prism. So all that light from overhead is sort of broadcast to your eye, creating this very luminous surface over which we're running that chilled water. So the idea here is that it's really a space through which everybody entering the building has to pass. So there's a moment in time in terms of each person coming into the building that you're sharing this motion of moving up to the 3rd floor, down to the ground floor, passing through this sort of rippling field of water. It's actually a cooling environment and has sort of acoustical value to it as well. So it's the idea of sort of bringing a fragment of what you would consider to be nature from outside of the city into this built environment, making it part of everybody's experience. Similarly, we work on multiple scales of projects, larger buildings, small buildings. This is done with a friend, Vincent James, a house in Minneapolis near the Walker Art Center, done for a couple who had a wonderful collection of art, wanted to move, had lived in the country for many years, and then brought their collection into the city, wanting to be close to the Walker, where their collection resides today. And their concern for this building was really to live in a neighborhood, but actually feel like you're still living in nature, you're living outside of the city. So we worked on all the glazing systems and a whole shading system for the building that allows these louvers to close down all of the rooms independently. And there's one window in particular, which is up here, going up to the 2nd floor, that I really wanted to speak to you about in a moment. And it's a window which has a problem that is not unusual. It's a window which probably 80% of the windows in the world share, which is a window that really doesn't have a view. And we took this idea of a window that had no view and tried to understand how a window might collect information from outside the building, bring that information in, process it, and then project it into the building so that the window actually is a real-time collection of fragments of information happening outside the building. And the way we're sort of doing that is quite simple in terms of optics. Here's a little mock-up. This being representing the sky overhead, the building, like looking straight up, because outside this window is actually a stone wall, an opaque wall, and another building, which we didn't want to have the client see. So the window as like a periscope at a different scale than what you just saw at the Hearst building, using the periscopic principle, series of mirrors built into the window itself, and a series of lenses that sit in front of each of those mirrors, and then a sheet of diffuse glass that resolves the image at the right focal length from the lenses and from the view of the sky overhead. So it's basically an optical device that brings the outside in and allows you to reconstruct it. So here you sort of see images of fragments of direct sun hitting the instrument itself, but you also see the shadowing of a treetop in the distance behind. So each lens is roughly the size of a small video monitor. And this is the window under construction. This is actually the view out the window. So like I was saying, there's not really a view. There's actually obstructions to view. And then this is the window once the diffuse glass is installed on a very bright day. Each of those images you see is basically a view of the tree beyond. So here you see a blow up of it. This is a tree off in the distance, treetop, sun coming through that very same tree, projecting shadows of the leaves themselves, and then the lens is sort of collecting light and projecting images of the sort of phenomenon of these discs of light that the lenses are producing. So the window is actually operating all the time, different weather conditions, different lighting conditions, collecting, creating sort of a synthetic view. It's actually sort of a constructed view of the nature outside. And what's interesting about this window is that on different times of the day or evening, like say in the winter, if you have like a full moon, every single one of these lenses will be projecting an image of that moon overhead. So just like this tree in the distance, you'll see the moon image brought into the space. So it's something that always has a connection to the exterior, but a connection which is definitely modified in terms of how you interpret that connection to the exterior. And this is taking this to another scale, how you think about working with bringing qualities of nature into the city or into an urban environment. I'm going to talk about this tower, I think, at the end, the latter part of this lecture. But at the moment, I'm just sort of talking about this particular project here. This is Broadway, and this is Fulton Street. So you're right down near the World Trade Center site here. So this Fulton Street project was done with Arup and Grimshaw, and it's a relatively small transit center downtown. And its significance is that most of our subway systems in New York run north-south. You're certainly aware of like Grand Central and some of these other places further up in the city, or Penn Station, where many subway lines sort of converge and you have an opportunity to sort of transfer between subway lines. But downtown in Manhattan, the lines all tend to converge and they get relatively close to each other, but there was never a way to sort of connect them together. So this project was really sort of done after 9/11, but it was really a way to improve connectivity between the subway lines. And our project here is basically this primary device which brings, as I'll show you, sort of an image of the sky and daylight down into the below ground environment. But it also suggested how each of the subway entries might bring daylight and use light as sort of a wayfinding principle throughout the subway system. And what you're seeing here is what would be called a radiance, an early radiance study. I mean, these programs are quite more sophisticated than this now. This is probably done back in 2004. But you're looking at a section through this structure. It's a glass, a small, it's maybe a 2-3 story high glass pavilion. Goes down below ground 2-3 floors. And our project was this skylight overhead and this form that you can see here. It's sort of a toroid, sort of an eccentric toroidal shape. And you have to look at this shape because you don't recognize this shape when you're looking up at it. It looks much flatter and sort of fuller. But the principle here is that this form, which is a cabled net, is clad with a type of aluminum. It's an optical aluminum, and it has a texture on it which allows for basically capturing the image of the sky and capturing views of the sky. And the shape is really, the significance of the shape is that it's changing the aperture of the skylight. And by that I mean, if you didn't have this structure, your view of the skylight would be defined by this blue cone. That's the cone that most skylights give you, the view of the sky directly overhead. It's defined by the perimeter of this opening. By changing this shape, in fact, when you look up at this side right here, this curvature is in fact giving you a view of the sky from a much more oblique angle. And vice versa, looking up here, you're actually looking at this angle of the sky. So you can imagine you're actually getting a view of sky which is this broad. It's actually this entire view of the sky rather than the limited view that you get from this sort of skylight overhead. And you can imagine if this figure was moved over here to the stairway, the skylight view is even more restricted, but you actually have this entire surface giving you a view overhead. And what this does is, you'll see what happens to this when you are inside the building, but this is the structure. It's optical aluminum, as I said. It's fairly highly perforated, and the perforation level, the porosity level basically changes based on the sort of fluid dynamics of the space itself. This net is doing two things. It's one, increasingly the daylight brought into the building, but it's also masking the smoke evacuation system that exists behind it. So that whole form that you saw is basically called a smoke reservoir. So the smoke would rise up into that space and it's evacuated through this net should there be a fire in the subway. So all the equipment for smoke evacuation exists up in these upper levels of the space. And this is the space obviously before the net is installed. But this video gives you an idea of how this is done. It's completely predetermined. The form finding has been done. The determinations on the cable net are all predetermined. It's attached to a compression ring at the top of the skylight up above here and tension down to one compression ring down at the bottom. So this has no contact with the rest of the building at all, just the one disc at the bottom and the disc at the floor level. And you saw the men installing the panels. And you can sort of see through the material, as you can see here in this photograph. But on the opposite side, you can see that it's very, basically the brightness on this material tends to defy your eye going through it. So there's all the smoke evac equipment behind it. And then down below, the view that you get inside. This is still under construction, but it shows you what happens with that form. This is obviously the blue sky outside, and these are actually clouds. These are clouds in the sky beyond. So what's happening is you've brought the image of the sky down and into the building. You basically captured the sky image and projecting it real time into the building. So you can stand here and see the movement of clouds or sort of the change of sky color as it happens through the day. So it's sort of a principle of how one can really change one's experience of light availability in the city. Because if you walked outside here on Broadway, your view of the sky is very constrained. You have all the tall buildings around you. you see very small fragments or views of the sky beyond, whereas this device begins to give you this other sense of the sky, more sense of the sky as you experience it outside of the city. So a lot of our projects try to deal with these types of phenomenon. And in this instance, obviously, you know, back before the pandemic, you know, you'd have, you know, basically about 300,000 people a day move through here. So you always have this sort of shared looking up, so the shared view of the sky becomes very much of sort of a collective experience of people moving through the space. Not far from this particular project was a project that we did after 9/11, literally started a few weeks, a month after 9/11. This is obviously the World Trade Center site. Post 9/11, the building we're talking about is this building here, which is Tower 7, this building, first building built after 9/11. It was critical to get this building up immediately afterwards. The client for this building is Silverstein Properties, who are also the developers of the whole World Trade Center site. This particular building was across the street from the main World Trade Center site. And the building that existed on this footprint was the previous World Trade Center Tower 7, which is the building you might recall caught on fire and it sort of collapsed upon itself later in the day. Nobody got hurt. But the significance of that building was that it's actually a Con Edison station, a big power distribution transformer station for downtown Manhattan. So when this building collapsed, took out most of the power in downtown Manhattan, and therefore this had to be built very quickly. So this, what you're looking at, is really the rebuilt transformer vault, which exists at the base of the building. And this was our immediate task afterwards. And we're hired in this instance directly by the developer to work on the skin of the building, obviously collaborating with Skidmore. And this piece of the puzzle was recognizing that downtown was going to change dramatically relative to pedestrian activity on the street once this came back, because the former World Trade Center site existed upon a super block. It was a high podium that occupied 4 city blocks, and it was not very conducive to pedestrian activity. And that super block being gone, all these streetways now become open, and today it's more of a pedestrian environment. But this concrete block, obviously, as the base of a building, is not someone thinks of as a friendly neighbor in an urban environment. So we worked on an idea, which is shown here in one of the early drawings, of mapping reflected light on the surface of that concrete vault. So what you're looking at here is one of the facades of that concrete vault system, as if you were standing here on the street looking away from the building, like with your back up against the building. Where is the light coming from? Where do you have openings in the building profiles of surrounding blocks? Where's the light coming from around you? And if you are in the city, of course, if you stand on one of these narrow streets downtown, the majority of your light is coming from down the streets. So it's really coming from your left or right. So this whole skin is based on programming the skin of the building to respond to light. In order to do so, and these are very early models, imagining an exterior skin that would eventually be done out of a stainless steel prism, and then lighting the interior skin using 2 skins, one daytime skin, one nighttime skin, to clad the vault. The reason being that these transformers can explode and you need to restrain whatever might come out into the street to harm the pedestrian. So this is the final sort of configuration of the screen system. It's prisms that are rotated. The prisms on the right here are slightly rotated about 15 degrees, and these are sort of oriented to the face of the building. Then a second skin of prisms at the back. Those are more diffuse finish, and the front ones have a slightly different finish. This, you see one of the panels being made. by a company that does actually water filtration systems. They'd never really done a architectural project before, but you can see the prism construction, the rotation of the prisms here, and then how those prisms behave. They sort of can take light coming from different angles, and they bounce the light at different angles back to the viewer's eye. Nighttime, we're sort of lighting the inner skin from an LED system that's built within this vault cladding. And here you have some of the initial panels going up on the building. Behind, and you can see how you sort of pick up just random field. This is just daylight being bounced from an adjacent building. You can sort of see the window pattern. So it's a surface that's responsive, basically. It's a surface which, if you have a light event, it will turn it into something exceptional rather than something lost within its environment. And then this is that same system looking at the corner, southeast facing corner of the building, but it tells you how this is working. This scrim is in fact 50% open, because the whole wall is 50% open to allow for natural ventilation of the transformers behind. But as you look at it, your eye is actually confronted by a brighter surface. And even though your eye can go through this screen and see into the vaults, it doesn't do so. It sort of stops at that front surface, and then in the evening, it'll pass through that outer scrim and then stop at this inner surface. So you never really see the vaults themselves. It's either illuminated artificially this way, so it glows at night from within, or it's sort of lit from daylight from the exterior, and you have that environment. But it's basically applying some of the same principles, I've talked about in some of the other projects, but applying them in a different scale, in a different way. And as if you look up on the building, I think one of the things we all came to understand about being responsible for putting up the first building after 9/11 was it had to be something that was exceptional relative to how it related to its environment. So that lower part of the building, which is that vault system that you saw, is clad that way. But the tower is actually clad with this idea, which is taking what is the spandrel or structural section of the building. This is where the big steel work would be supporting the floor above. This is the upper floor above one level, coming down to the ceiling of the next level. The curtain wall basically spans from one floor to another, and the spandrel is often an opaque material, or it's treated with a pattern or something to sort of distinguish it from the rest of it. But what we've done here is taken a moderately corrugated surface, built in a reflector at the sill, a blue reflector here, a blue stainless steel reflector. And the principle is essentially that sky brightness coming from up here comes down, bounces off of this reflector, and pushes blue light back up into this spandrel panel. So that's demonstrated here. This is a conventional piece of corrugation. Obviously, the lower part of it is actually shadow, but in this instance, you're actually pushing blue light back up into the spandrel panel of the building. And the whole idea here is, you can see some of the blue light here bouncing up into there. The whole idea here is that what you read on the surface of the building are these free floating panels of glass that stop sort of midway across the spandrel floating, and then a background of light, sometimes blue light, sometimes just bright light. But when it's blue light, it can sometimes merge with the blue of the sky beyond. So that's the principle, that this part of the building merges with the sky beyond it, and you just read this sort of cascade of glass elements coming down. And of course, all these projects, you're doing larger, smaller scale mock-ups, larger scale mock-up, which is more of a, this is more of a visual mock-up, all different configurations of systems here, which are then studied and then sort of hoisted up to different heights to study them. And then eventually the whole project being installed. So here you basically see this building, which is a field of daylighting reflectors built into the skin, which change at all times of the day It makes the building very, very responsive to its surroundings, and also very, very, very responsive and visible from great distances away. So it's something you experience close up, and then something you experience from great distances. So looking at the base of the building up, you have both that sort of field of stainless steel prisms gathering light sort of horizontally, or almost sort of parallel to the surface of the ground, and then the other tower actually gathering light from above, and sort of both of them sort of representing two different approaches to how you would read this tower against the sky. Moving to a slightly different scale, but also sort of addressing some very different approaches to working with light. This is the Israel Museum in Jerusalem. And this is about a building done in the early 1960s, done by an emigre architect to Israel, Alfred Mansfeld, coming from Germany. He was an adherent to sort of this non-hierarchical sort of program of how buildings could address sort of a universal access and be clusters of smaller entities and could continue almost infinitely, sort of an open grid plan. Their buildings are all made out of concrete, and each roof is basically supported by an independent column at the center. So the roofs are in fact not actually connected to the walls except at the corners. Very small, very hermetic. When you enter the building, you don't quite understand where you're going, orientation. This had some temporary buildings built, some work, the former addition done in the late 70s, done by a fellow named Jürgen Boe, who did the Louisiana Museum in Denmark. And this is a beautiful building that houses the Dead Sea Scrolls. Our job was really to come into this project, the gardens all done by Izumo Noguchi, come into the project and sort of reorganize the circulation, bring it up to ADA accessibility, and then strategically sort of remove some structures, specifically this building here, which is a temporary structure, this building and these buildings, and create a whole new sense of entry into the campus and how you would bring people from the entry point up into the first exhibition pavilion, which is up here, which is up about a 50-foot high difference, 45-foot high difference from here to there. All this was done through ramping systems and little vans that would drive you up. So this planning had to do with, first of all, this notion of how you sort of reorganize the key buildings, adding a new exhibition building and restaurant building, cafes, service, conservation underneath, big building underground here, new bookstore, new security and entry, then bringing you up underground to a new building here, and then connecting into the renewed and sort of restored galleries below, and working on the gardens in terms of bringing that all up to ADA. So that's basically the scope of work for the project. And then this is sort of the excavation of that campus up to the core of the campus. And this is a tunnel that's put in, sort of mechanical service tunnel coming in on one side, access tunnel coming in the other side. So this is that same space below ground. You are going from around 18 feet below ground up to about 50 feet underground here, and how you make that feel like you're in a daylit passageway, connection to the landscape with these courtyards and gardens, but sort of a sense of moving through the campus, but not realizing you're actually that far below ground. So we tried to keep this character of fairly intimate, smaller scale buildings, which are, these are some of the original buildings, which dealt with daylight in a very, very obvious way. East, west, and south, very small windows, limiting the amount of light entry to the buildings. North window would have more light, larger windows. So they were dealing with light around the top of the buildings and restricted the light. And again, you didn't really see out from that. So we started the project thinking, okay, we're going to work with these smaller pavilions, but we need to have an idea for handling light in the Middle East that allows for a connection to the landscape outside, connection to a very beautiful environment, Mediterranean gardens, and basically sort of a botanical garden next to you. So what you're looking at are prototypes of what they're louvers, yes, but we call them more like foils. These are different shapes that were being studied. Fundamentally, this is a shape used on the east and west elevation of the building. This is the bottom of the louver. This is the top of the louver. It has this sort of curve to it. This is flat to the face of the new buildings. And this is the north-south foil or louver. And the whole principle here, because we're on a hill, is we had literally sunrise and sunset. So we had light coming in due east and west. So this is the east-west louver here, which is having to stop all of that light. So this is again, a radiant study of how that louver works. So you have very intense light from the east and west. You can see the light is bounced into that little cove, and the light is pushed up on the interior surface of the louver above it. That's happening in all these cases. The louver above sees the bright light down below. So this is a shading device on this side, but it's actually a lighting device on the other side. So it's a louver, but it's not behaving like a louver. It's actually a daylighting system for cutting back the intensity of light of this environment, moderating it so it becomes an indirect light source from the inside. North and south, obviously, the altitude of the sun is much higher in summer angles and even winter to the south. So this is a deeper louver, placed more frequently, but this again stops 100% of direct sun getting into any of these buildings. So we started from that premise that no direct sun would get into these buildings at all. And by doing so, we were able to reduce the mechanical systems by about 30%. So they get no solar heat gain at all. And the glazing on these buildings is actually just laminated low iron glass. There's no insulation, no coatings, no dark glass. All those things that you would typically use in this environment are all sidestepped because they don't get direct sun. But the principle here, which is, I think, of interest, is that when you have trees outside or anything happening outside, you see how this works. The light hits the scoop, that information is actually transferred to inside the building. This is the inside view of the east and west elevation. So you'd have shadows of trees, colors of trees, all of that sort of stuff comes in. And this is sort of looking down on it. Extrusions, terracotta ceramic extrusions. This is the east or the north-south. What the north-south does is that it allows you to actually look into the buildings, which you were never able to do previously. You can actually look into the buildings, see when they're being occupied, see when the museum's open, see when the restaurants are open, and see activity in these buildings. Prior to that, they're all like this. They're basically opaque boxes. You had no idea if the museum was open. So this louver idea is shown here, and this is creating, this wall is, these walls exist between, say, 1 meter and 5 meters away from the glass wall. So this would be an example of the shaded walkway. All the circulation is in shade. This is your clear glass wall inside, floor to ceiling, and this is the shading device here. So no light gets into these buildings. Here you have, trees and activity. This is right after the trees were planted. So you have all that sort of happening, projection surface inside. And this is why you can see, this is looking to the south. You have views out, there's no direct light coming in. Views to the north, obviously less light coming in there, but you have this connection to nature outside. And all the walkways are either open breezeways or other things. And this is walking into that below ground tunnel. Here are the people walking in the garden up above. So you can still do the original route, all been reconfigured to meet ADA up above. Or you can come into this below ground passageway with these courtyards that takes you all the way up to the core of the campus. And then here you are. This gives you an example. This is at the end of the tunnel here. a little courtyard with greenery coming all the way down, so you feel connected to the landscape. But this is ground level up here. This is grade up above here. So you're that far underground. This is a west-facing wall, and that's western light. It's all kept out, but that's that deep louver that you saw before. And then in the evening, that passageway below ground is lit in the daytime by this glass fountain or water feature that runs down the center of the campus. So that whole passageway below ground is sunlight coming through from above, passing through water. It's very active, like inside the below ground space, very cooling and sort of very subtle inside the space. But you have this wonderful landscape, which is now connecting to all the buildings. That's one of the new buildings inserted into the campus there. This project is similarly working in a below ground environment for the most part. And that's funny enough, actually, how we get involved in many projects. This is the obviously St. Louis Arch. It's a photograph from the top of the arch. A project that was a competition. We were on the team with Michael Van Valkenburg, landscape architect. We won the competition, and Michael obviously redoing the entirety of this 80-acre park, redoing the shoreline here and getting better connections for the public, redoing the Kylie landscape, restoring what was possible. And then our job was really taking the original lobby below ground, which you would enter the museum originally here, go into the lobby, get on that little ride they had, and then you would take a little ride up to the top of the arch from which this photograph is taken, and then leave. And there were some parking lots in the garage here. So many visitors would just come and go to the arch and wouldn't go into the downtown. And the city was really separated from this site. Like, this is a view after a bridge that was part of our project was put in place. But originally you had surface roads running across here to the west. You have a 6-lane open highway interstate running between you and the downtown, and then another 2 lanes of surface roads on this side, and then access and exiting ramps off of the superhighway. So anyway, it was never a pleasant experience to go from downtown to the park. So the main part of this project was primarily to create this much closer association with downtown and ease of access and a much more generous approach. So that required a new entry, which is really our responsibility here, and then redoing this part of the existing building below ground. So this had been underground for 50 years. And when we first started the project, a lot of the offices were under here. Almost every office had 3 or 4 waste baskets collecting water, dripping in through the roof. So had to excavate the whole thing, re-waterproof it, and then this new entry. So upon arrival, all those surface roads were in place. And this is basically our scheme, coming from the Mississippi, redoing that whole waterfront, the sort of abutments there at the water's edge, stairs. This is the original piece of the museum here. And then this is the whole new piece that's been added, covering the highway here, and then redoing this garden park, which obviously is Michael's scope, and then a historic courthouse here. So now you have this courthouse with this new entry, which you see here, with a new landscape between them. So it's actually a new civic space, sort of at grade, and then this then leads you into the below ground environment and down to the below ground spaces and up into the arch itself. So these are the original Saarinen model here, a model in our studio right here. This would have been right behind me from where I'm speaking. But basically defining that new entry, sort of the new space to get down from the surface down to the lower level, and then the renovation of that lower environment below. And as it was when we arrived, here it is, 2 lanes of surface roads here. That 6th lane is between you and the other cars on the surface over there. And then this berm that Kylie used to basically cut out the sound of the highways and all the noise. But you were just crossing at these traffic lights. It was very unresponsive to the work and the sort of the beauty of the site itself over here, but also unresponsive to the assets that the city had on this side. So this process, went on over several years, covering the highway in the foreground there. You just saw that going in, excavations of the existing building, bringing about this new entry up front here, sort of a welcoming entry, which was so quite difficult to fit in because the landscape itself is sort of listed, meaning that this berm, which is the Kiley berm, was an established elevation and character of the site that had to be put back at its original location and elevation. And at the same time, the highway running right under here had a retaining wall that couldn't be changed. So we couldn't go any lower than this point because of the highway wall, and we couldn't go any higher than this on the other thing. So you just imagine this like wedge that's sort of sliding into the landscape. And in order to make it universally accessible, it created this shape. We needed this much distance to bring you to the entry so that it was universally accessible. That's looking back from the top of the arch over the highway there, and then to the original park that was there. So this is everything that was removed, all of this stuff here that you see. And then that's what went into place. These are early models. I mean, again, one of the tasks here was you're bringing people underground after being out in this beautiful landscape. So how do you sort of make that transition very sympathetic, basically, to the landscape, fully integrated in the landscape, but also make that a very smooth transition relative to changes in light levels and the acceptance of daylight below ground and artificial light, having them coordinated together. So this is right here in the office, a mock-up of a lighting system that we designed. We had obviously deep concrete beams to span over this 100-foot wide space. They're like 5 feet deep. So this grid or system of tubes floats underneath that deep beam system and vault system between the beams. And then we're lighting up into those vaults, basically. So it's all uplit against an optical aluminum ceiling. So it's bouncing light back down. So here you have it. It's sort of like this lit space below. Sort of feels like a lot of people probably think it's skylit, but it's all artificially lit. And it transitions from this space here, the canopy, to this space coming in underground and then below ground. This happens to be a photograph. This is one of our things we wanted to make sure we did do. This is actually sunlight, and this is about 300 feet below this entry. So you're underground and deep in the building, but you still have light, sunlight, late afternoon, getting all the way into the building. So anyway, just a very wonderful project and a wonderful process working and transforming this whole part of downtown St. Louis and rejoining the city to the river. And just briefly, I'm going to quickly talk about two other projects. This little pavilion done with Reed Hildebrand, landscape architect, for the center of the campus at the Harvard Business School, essentially surrounded by a lot of brick buildings, the core of their campus, but a small pavilion that was essentially sort of put forward by the dean to give the students a place for their own activities and a place they could program for themselves, not necessarily have a program by the school. These are early mock-ups of what we're trying to do here. It's a beautiful campus with, basically specimen trees surrounding it. There's a portion of the pavilion that's partially enclosed. It faces, this is south over here. So this enclosed part gets a lot of south light in the winter, to warm it up. And then this is basically just a covered canopy that adjoins the big part of the common. This then has a fabric roof that's attached to it for covering up for large events, like where they have events for 200-300 people out in the lawn. But it's essentially these curved glass elements and then a gutter system underneath. But it's the notion of having these glass roofs. You can see it here on the right with this video. You're under these beautiful trees, and we wanted to always make sure that the landscape was sort of part of your experience within the pavilion. Sense of privacy behind the diffused glass, but with the roof itself sort of being animated by the movement of leaves and the trees around it. You actually feel you're not under cover per se, you're out of the rain certainly, but you're sort of similarly being shaded by the tree canopy above you. So a small project, but one that has actually had a lot of success relative to student use and active use with on the campus. And then just to leave you with one last project, coming back, I guess, to this idea of being inspired by nature as sort of a grounding or foundational grounding for a lot of our work. This is Palo Alto, California, or Stanford. This is a type of weather condition that comes over the mountains, obviously from the ocean, which is quite cold on the other side there, and meets sort of the warmer air of the Bay Area or the San Jose area, the Palo Alto area. And you get these beautiful fogs that sort of like cover over the treetops. So this was actually a competition put forward by the president to take this beautiful amphitheater, which had been fallen into, I'd say, sort of disuse or minimal use. It always used to be where all the graduations took place and huge concerts in the 60s, with the Grateful Dead and Jefferson Airplane, all these famous concerts. But as the class sizes got larger, most of the graduations moved to the stadium, and they have individual graduations for different schools. But the president wanted to be able to seat within this bowl between 2,500 and 3,000 people under a canopy so that they could have lectures regardless of what the weather was and do that. But these are some of these great concerts in the 60s. It sort of gives you an idea of this bowl. And our design is really what you see down below here. We came up with an idea for a canopy to double curvature saddle, sort of anticlastic form, defined by cable net structure done with Schleich-Bergerman partners or our engineers. The canopy itself resides back here. It's essentially sort of a garage that holds the fabric. This is sort of a wood ceiling over the stage. And then this is an open cable net out here. Obviously the stage here, sort of a dining area for special events back here, seating, covered seating here within it. But the idea to keep in mind here is the canopy sits low within the space, sort of, again, below the treetop level. So we wanted to capture this intimacy of this space and use the shading and cooling of the woods around it to be able to draw the cool air down in and exhaust it out through the back. So the canopy is essentially a climatic controlling device. It's a deployable canopy. Obviously, you could deploy it in summer for shade and keep the ground cool in the summertime. Retract it at night, let the heat sort of go up to the sky overhead. But you could cool the environment significantly in the summer and just the opposite in the winter. Let the ground be exposed to winter sun, deploy the canopy to capture that warmer air and raise the temperature of the enclosed space. That's one reason to keep it a little bit more intimate. So this is the canopy, and so you sort of see how it fits into the bowl shape. It's almost like a mirror image of the bowl being a double curvature. And then this little video will give you a sense of what this looks like within the environment. So what happens during late afternoon and mornings is the shadows of the trees basically play on the canopy overhead. So much like that roof that was done for the Harvard Business School, you have a sort of a play of the surrounding tree canopy on the roof overhead. So the reflectors you see are built into the cable system. They're not part of the structure. They're basically just reflectors that bounce some of the light from the north down and protect you from some of the sun. But the fabric comes out. They're on cars that are pulled out, and then it becomes a taut form once it's deployed. It takes about 2 minutes to deploy. And then it's tension and position. But there you see sort of the shadowing. So if you were underneath that, you would have that sense of the tree canopy sort of extending overhead within that environment. So again, I mean, our offices, and we're very interested in structure and light together. We love fabric structures. We try to work on them whenever we can, but try to keep up this whole sense of closeness and sort of connection to nature in sort of all of the projects we do. So I know I ran a little long on that, but I will be happy to answer questions. Okay, there we go.
So James, thank you so much for showing tonight like some of your fascinating work. Very, very inspiring indeed. We're gonna start our Q&A session. So I'm gonna start off by asking a very important question. What do you think, at what stage of the design you could be involved in such development that you showed us? Like, is it through a concept or in DD, like after the building envelope have some ideas about it, and then you come to the game to enhance like, for example, one of the most fascinating solutions, which the one with the ceramic louvers that allowed the visitors to be able to see what's going on in the building, allow this transparency without really compromising the heat gain or the indoor air quality. So from your experience, what would be the optimal time, or what time do you come in the table to start to really have an important input in all these concepts?
Well, generally we're there day one. I mean, we're there at the beginning of a project, and many of the projects are sort of, we're actually acting as the architect as well. So we are sort of designing the work and engineering the work very early on, trying to implement many of these ideas. I mean, most of these ideas obviously have to be part of the foundational thinking to be successful. It's less productive, I'd say, or less productive for us to get involved later. Certainly make things of the sort, but to actually, from our perspective, have a role that's significant enough, we typically need to be involved very, very early on.
Right, and one thing also that I noticed, that there's evidence of really high quality research that's the backbone of all these concepts. So some of them are, it seems like it's a research designed or work directly to address issue of certain project, but can you elaborate more about what would the firm do during time when it's not directly working on a certain project? Like, you engage in always continuing learning about more of these applications aside from a direct need for a project? Like, that's something I noticed. Like, usually in practice we have a research department, but we try to explore new and novel ideas until maybe a proper project happens and we start to apply it. So could you more about that's happening in the background? That's what I'm interested in. Yeah.
Well, I mean, I can't necessarily show you my studio, but maybe get a little sense of it in the background here. But we have about 5,000 square feet, and it's really as much a workshop as it is a studio. We certainly have drafting and computer and all that, everything you would expect to have in an office of this sort. But we have a huge library of materials which is just surrounding you all the time. And we are doing a little bit what you just suggested. I mean, each project pushes us to sort of come up with an idea that's highly specific to that project, but it might take you several iterations of exploration to get to the right solution. But along the way, there have been other things considered that may not be immediately relevant, but eventually do become relevant. So there's always that idea of a building up of a library of knowledge, both in terms of materials and manufacturing and basically performance, which, I mean, that's sort of our studio is really very interested in performative aspects of these projects as much as just their pure aesthetics. I mean, it's sort of light, thermal performance, you know, all these characteristics, because we think it makes the solution obviously much more, much richer and obviously more pertinent to all these issues of cost, you know, which in a building, like if our project can do 2 or 3 things at once, so much the better. So we try to target that. You know, we really try to target things that can be sort of multitasking as elements within a building. So.
We just received a question from our school director, Professor Jason Young. He says, beautiful work. Thanks for sharing. You mentioned it a number of times in the passing, but could you speak directly on how computational has changed the work, how you work, and how the types of things you can work on?
How competition or how?
Computational design, or how like from the early time of your research, you use some analog form finding, but then later on you showed some computational.
Yeah. Well, actually, I think, now I think we have, obviously, my sort of practice sort of dates from really hands-on physical model making, all of that. So we have not moved away from that. And I would have to say that working with light, light is scalable. So it's actually something you can do very small scale tests, and it'll tell you exactly what's going to happen at a much bigger scale. But we certainly on the engineering, we're using, a lot of analytical things on structural engineering, but also in terms of light, of course. I mean, the radiance program, which is sort of exploded in terms of lots of add-ons to the original radiance program that allow you to do enormous amount of research and information gathering, do that. So we do computational, but it's definitely married with hands-on materials simultaneously.
Yes, I'm really fascinated with the project in the museum in Israel, especially when you showed the different prototype profiles that was sitting on the table, and then you showed the simulation of how the radiance how close was the computational simulation to how it actually performed in real life? Like, which one do you think was a better judge of how these Lubar will perform? The physical model, the large mock-up model, or the computer simulation, or they were very close?
Well, very close. I mean, I think that the whole thing, of course, is that with the physical model here, we like, I have a model right here that's 12 foot tall for a new terminal building in San Diego of a different type of pre-Soleil system that will eventually go into that building. But we'll have this here, and this is all light. This is all exposed to light over here on this side of me in the daytime. And we will keep this up for months just to sort of look at it over time. So there's a certain comfort level that you build up by having something with you for a period of time, married with what the computer is telling you about different times of year, different altitude angles. I mean, all of those things you can do fairly quickly in the computer. But to my mind, there are things that also need to be allowed to sort of gel in a little bit longer time frame. You need to understand how they transition from one thing to another. So there's a little bit of intuition to begin with, which is informed by a lot of experience. There's the computational, I'd say, investigation, exploration, and verification that takes place. And then there are these things that we have around that are often helpful because you just notice something over time that you wouldn't, instead of looking at the computer screen, you're looking at the reality, and all of a sudden something speaks to you about what you should do to improve it or make it better. So I think that all those things are important, and a lot of that I learned through, I worked at Corning for quite a long time, and a lot of the glasses that we worked on, you could understand them conceptually, but until you actually produced them and worked with them, it was very hard to really realize what their potential was. So that stayed with me. So
Yeah. We just received an anonymous attendee who's asking, what's your recommendation to a first-year student who is just beginning to explore how light affects architecture, and what are the most important aspects of these considerations?
yeah, I think there's always this idea that architecture, is about revealing light. And I always look at that the opposite way, that light is sort of revealing architecture. So I sort of give the preference, I guess, to light when I think about things. But as a first-year student, I think this whole idea of just understanding, doing models, physical models, is very, very helpful. If you're in a class, studying some computational things, always try to combine it with some physical model making simultaneously, because it's enormously helpful in terms of building confidence. And I think that's important when you're doing computational work, that you have confidence in the outcome. And confidence, I think, comes from both the physical as well as theoretical, until you've actually built it. So there's a need to sort of have the two in your mind all the time, sort of balancing one another.
True. Some of the most fascinating models that I worked with, we just built some small models and tried to get with a small camera inside, and that the best light simulation would happen through these, and they would give you a quick and much more fascinating feedback than an hour wait of renderings. It's just a matter of some.
Yeah, exactly.
So we got a question from Professor Lisa Mulligan. She said, thanks for sharing your work. It seems like the sense of movement in your work, like shadows, is as important the light itself. Is that true?
Absolutely. I mean, I think light. Actually, when I think of light, as well. Okay, here's how I start thinking about it. Like when you're, I don't think about light per se, just like a beam of light hitting something. I think more about the illuminated surface and how your eye responds to that. And when I think about light as it affects our perception and surroundings, I always just in my mind think about, okay, here I am, I'm sort of in an open field looking into a forest. I'm looking at literally billions of surfaces that are all individually illuminated. And each one has a different level of illumination and activation to it. And my eye is obviously grossly simplifying that so I can sort of understand it. But I try to keep reminding myself of the complexity of that overlay, where things are happening within a depth of field. Your eye is sort of compressing everything, but there's an immensity of depth of field perception and sort of objects that are merging and actually sort of coalescing to create the bigger picture. But I always try to keep pulling those apart, because I think each part has sort of a role to play in our understanding of our surroundings. So that's the idea. Yeah, you get the shadow play happening. All of these things are informing us in a very different way. It's not just the light, it's the movement and the shadow, different levels of light simultaneously. So all of those things sort of comprise my understanding of the study of light. So,
fantastic. We have maybe one time for one last question, which is, it's going to be coming from me. You know how sometimes architects create these amazing, fascinating work, but my question to you, if you decided to do something for your own house or for your own, like how much this do you think would be influencing your design, how you experience your own space? Do you apply any of that work in your space, in your house, in your?
yeah, I do. I'd say obviously in a more, since it's for yourself, it's done a little more modestly, I'd say, because you don't have the budgets available that we might have elsewhere. But yeah, just like we did something, my wife and I did our loft here in New York, which was originally just a very simple, relatively small space, one floor. Its unusual characteristics, it had a high ceiling. And we basically just took it apart. We sort of tore part of the roof off and went up and did it. But in a small space, having multiple ways of light entering that space, certainly a series of conventional windows facing east, but bringing light over with a north-facing clerestory, and then light sort of coming in the back of the building, washing the back of the walls. So basically, we created an environment that most anybody would think it just has light from one side, actually has light one side on top and in the back. It was just doing some very simple moves, but the whole space is filled with light. And otherwise, it was a shoebox.
Yeah, in fact, this is what I love about the knowledge in architecture and research and the work that you do is that, like recently we were doing a studio in Mozambique where I encourage students to do. There was a lot of sustainability, a lot of these techniques that cost nothing, like just for free, but just having the right orientation for the building, introducing the right aperture. All these maybe a local builder would just like oversee, like they can't really notice these things, but as architects, so you have a planning, and so there. I'm really fascinated with techniques that architecture and designers, based on their experience, can introduce to a space that costs nothing, but really can enhance the space tremendously. And
Right.
that's some of the really beautiful work we saw today is that nothing really is like louvers has been existing in very long time ago, but how do you use them? How do you change the profile for them that can make such really huge impact? And across the body of work that you showed tonight showed how the creativity, the cleverness, the being diligent about research and taking one parameter such light and shadow can really enhance the space. Majority of the project also you showed, even you might collaborate with really like world-class architects, but the part that you introduce to it, that's actually makes it sing. That's actually what really be the most significant part in the building. Does it make sense? So because really bring all these together to make like a jewel or a gem with playing with all that light, which is like, I think it's the hybridization between engineering, architecture, and also art. Like I saw some of the work today was like fascinating, like fascinating art installation. It's not architecture. It's beyond just a curtain wall or beyond an oculus in the ceiling, you know? So.
Well, I think that's a little bit of this, I think we all share sort of obviously we all share a connection to nature. We all, and oftentimes living in an urban space, you don't think about the presence of nature. And a lot of the work we try to do is just that. What's here? What can we sort of allow to come forward in terms of its presence that will allow people to have more of a collective understanding of this shared experience of nature, like in that transit center down here, where the image of the sky is basically folded into the building. So if you're in the building, the clouds are sort of moving in the building with you, and people notice that. And I think that's really important, that we try to arrive at these spaces or places or opportunities where there is this sense of a shared appreciation for the world around us.
Fantastic. James Carpenter, thank you so much for joining us tonight. And it was such a treat, and it was a pleasure to meet you, at least virtually, and hopefully one day we'll get to meet in person. Usually after that, we'll take you out for dinner. Maybe one day we'll be able to do that, and maybe I'll see you soon in New York at a certain point.
Great.
Thanks again.
Welcome, please.
Yeah, and have a wonderful night.
Good. Thank you so much. All right.
Thank you.
Bye-bye.